Good morning, students. Now I am going to start our chapter 3rd, laws of motion, and today we are going to learn about the force, classification of force, description of the different contact forces and the non-contact forces, and effects of force. So the concept of force gives us the quantitative description of the interaction between two bodies, or we can say or between a body and the environment. Okay, when we push or pull a car stuck in mud, we have to exert more force on it. Okay, this force may or may not be able to move the car. As you can see in that animated picture, the man is trying to move the car. Still, after exerting the more force, still he is not able to move the car. Okay. So force is an agent, generally termed as a push or pull, which can move or tend to move an object. It can stop or tend to stop an object in motion. Okay. Can change or tend to change the direction of motion of an object. And it can increase or decrease the speed of an object. So from all these cases, we can conclude that force is actually producing acceleration. Okay. So a force can also change the shape of an object on which it is acting. For example, when we squeeze a soft rubber ball, it will be deformed to some extent. So in other words, a force can be defined as an agent which can change or tend to change the dimension of an object, or produces or tend to produce acceleration in an object. Okay, so whatever the efforts are needed to move an object or to change its position or the shape or the direction which is mentioned above, these efforts called the force. Okay. So broadly speaking, force are classified as being of two types, that is contact and non-contact forces, and we will see different contact and non-contact forces. Contact forces, that means the force between two bodies when they are physically in contact. Okay, for example, such a force of frictional force, a normal reaction force, tension force, and force of collision. Clear? These all are the types of or a kind of contact force when the objects or two bodies are physically in contact. Okay. In the case of non-contact forces, when the bodies do not involve physically in contact, clear, but act through empty space, is called a non-contact forces or non-contact force. For example, gravitational force, electrostatic force, and the magnetic force, they all are the kinds of non-contact forces in which do not involve or the bodies do not involve physically but act through the empty space. Okay. So our first kind of contact force is the frictional force. Actually, this is all forces you have studied in your previous classes. Okay. So frictional force, suppose when we take a ball and roll it down on the ground, it gradually slows down and stops even though no one has stopped it. Automatically it will be stopped. Okay, this is due to the force of friction. Force of friction comes into act only when one body tries to move over another body in contact, Otherwise, this force does not come into existence. So, when the surface of one body is made to slide or roll over the surface of another body, a force arises which opposes the motion of the first body over other. This force which opposes the motion is called the force of friction, or in other words, we can say that frictional force. Clear? You can see in this diagram the ball which is automatically stopped. It shows the frictional force between the ball and the ground. Clear? Our next force is the normal reaction force. Suppose a box is resting on the ground or on the table. The box is exerting a downward force equal to its weight on the table, but it does not sink into the table. Why? This is because the ground exert, or we can say that the table also exert an equal and opposite force on the box, just normal to it, which is called the normal reaction force, or we can say that the action reaction force. Clear? So the weight of the box acting downwards is balanced by an equal upward force called the normal force supplied by the table. You can see in the diagram. So our next contact force is the tension force, as applied through the strings mostly. So when a body like a small metal ball is suspended by a long thread from a rigid support, the weight of the small metal ball, or that small metal ball can also be called a bob, which we have seen in that simple pendulum also. Clear? It acts vertically downwards. So an equal and opposite force acts on the string upwards, which balances the weight of the bob. This force is called the tension force, which is exerted through the string. Clear? The tension in a string is same everywhere if the string is massless. Clear? And it always acts on a string towards the point from which the string is suspended. Clear? You can see here in that animated picture, which is showing the tension force. The tension force that seen everywhere if the string is massless, or this force developed in the string, and it is always acts on a string towards the point from which the string is suspension. You can see here that T is the tension force. Now the next contact force is the force during collision. Clear? Suppose two bodies, suppose we can take a truck and a car are moving in the same direction but with the different speeds. Suppose the truck of the car collide with the other for a short while. During the collision, the truck exert a force on the car, and in turn the car exert an equal and opposite force on the truck. As a result, the two bodies move with different velocities after the collision. So due to this collision, equal and opposite forces act on each body, which make them move apart after the collision. Clear? You can see in this animated picture, which is showing the collision force due to or which make them move apart after the collision. As we have seen about the kinds of contact forces, where we have seen the frictional force, the normal reaction force, tension force, and force during the collision. Now we will see the non-contact force, where these forces come into act even though the objects are not in contact with each other, and these forces act through the space between the object. And the magnitude of non-contact forces depends on the distance of separation. It decreases with the increase of distance of separation. Clear? So in non-contact forces, first we will see the gravitational force. So this is very easy for you to understand the gravitational force. Okay, suppose a ball dropped from a height falls down. What pulls the ball down? The pull of the earth moves object downwards, and this pull is called the gravitational force. So the force of attraction exerted by the earth on all the objects is called the gravitational force. Not only the earth, but the other heavenly bodies are also exert the gravitational force. The gravitational force of the sun that keeps the planet in their orbits, or the gravitational force of the moon causes the tides in the ocean. It is seen that gravitational force comes into act even though the two objects, for example the moon and the sea waves, are not in contact with each other. So that is why it is the example of non-contact forces. Our next non-contact force is the electrostatic force. The force which exerted by the electrostatic charges is called the electrostatic force. Suppose if we bring a plastic comb close to small pieces of pear, nothing happens. But if we rub the plastic comb several times against our dry hair, that means not the wet hair or not on oily hair, and bring it near the pieces of paper again, they are attracted by the comb. Why so? This is because on rubbing the comb, it will get charge, and since the charge is produced at the site of rubbing and remain there without any movement, this force is called the electrostatic force, or we can say it is called the electrostatic charge, and the force exerted by the electrostatic charge is called the electrostatic force. You can see in this animated picture, which is the example of which is showing the electrostatic force. Now our next non-contact force is the magnetic force. Okay, suppose if we bring a magnet near some iron nail, any type of magnet we can take the horseshoe magnet or dumbbell, or we can take the that bar magnet. The nails move from their original position towards the magnet under the influence of magnetic force. It is the magnetic force of the magnet which exert a pull on the iron nails. The magnetic force exert a pull on the magnetic materials. What are the magnetic materials? Magnetic materials are iron, cobalt and nickel. Okay, so the force of interaction which exists between two magnetic poles. That means every magnet has two magnetic poles. So this force is called the magnetic force. Actually, this magnetic force acts from a distance. That is why it is also the kind of non-contact or the force at distance. Clear? So these all are about the contact and non-contact forces. Now we will see some effects of force. Now we will see the effects of force. Force produces effects on shape, motion, direction and the speed of the object. So the first effect of force is the effect on shape of the object. Take a balloon filled with air and press it. What will happen? Its shape changes. Or a metal rod bends on being given a few hammer blows. From this we can understand that force can make a change in the shape of the object. Next effect of the force is the effect on motion of the object. A force can make a body move and also can stop a moving body. For example, when we kick or an athlete kick a football, it moves through the ground. But when we catch it or when he or she catch it, it stops its motion. Now the next effect of force is the effect on direction. A hockey player strikes the running ball to change its direction. You can see here. From this we can understand that a force can change the direction of the moving body. Clear? Now the next effect of force is the effect on speed of the object. A force can also change its speed or change the speed of a moving body. For example, when you are paddling a bicycle, if someone pushes you from behind or pulls you back, your speed will change. Clear? That means force can affect on the speed of a moving body. So from all these effects, we can define the force. Force is the push or pull, which can make a body move, stop a moving body, change the direction and the shape and the size of a moving body. So after describing the force, now we will see the units of force. The SI unit of force is Newton, and the symbol of Newton is capital N, and 1 Newton is 1 kilogram into meter per second square. Clear? In CGS system, the unit of force is dyne, and 1 dyne is equal to 1 gram into 1 centimeter per second square. It has some gravitational units also. The gravitational units of force are kilogram force, or the symbol of kilogram force is kgf, and gram force is gf, and the conversion is given here. So in today's class, we learn about the very basic topic, that is the force, the categorization of force, and the effects of force. Clear? In our next class, we'll going to learn about, or we'll be learn about the Newton's law of motion. So that's all for today's class. Thank you and have a nice day.